Welcome to the Power Up Podcast. This is our third episode in our three-part series on artificial intelligence in the electric utility space. And I've been able to get the innovative guests back for this episode, including Anthony.contino from SBS. Ben Favreau's back for episode 3. We missed him in episode 2 from Black Veatch. Cory Byrnes from Beta Engineering. Josue Sanchez from Quanta Technology. Michael Bussinger from Burns McDonnell. And Shawn Weekly from Power Engineers. All joining us today for the final episode. And I'm your host, Trevor Scullion. And let's kick things off for our last episode here and start with AI's grand entrance into substation design specifically. And I want to ask the question, will AI revolutionize old school CAD workflows in design or just handle the boring bits? And let's start off with our good friend, Shawn Weekly.
I think that there's a really big opportunity to use AI and use agents and use things to remove a lot of the boring stuff that engineers and designers have to do. They don't want to get paid to fix title blocks and update properties and some properties and stuff like that. We should be able to automate a bunch of that, and then we should be able to create some agents or traditional programs to simply take that off their plate, because they go to school to learn how to design and build these substations. They're engineers, they have to pay a lot of money for their licenses and stuff like that. I don't think they see their time well spent doing the really mundane, low-level CAD stuff that can be automated via AI or otherwise.
Right. Yeah, you see a lot of that stuff now, right? Like a lot of that bill of material stuff, ballooning and automatic dimensioning and stuff starting to come alive.
Yeah.
You see a lot more of that, right? So, yeah, what about you, Cory? You think there's some game-changing design insights coming, or just going to handle some drafting?
Well, I think there's going to be a lot of downstream impacts as far as kind of proposal level stuff, high level engineering tasks, or at least high level investigative work, I think is where AI is going to have its first immediate impact for sure. One of the things as far as engineering impact goes, and there's kind of two folds to this, CAD versus engineering, but one of the things as far as engineering impact goes is engineering is a deterministic task. And AI is a probabilistic tool. So when it comes to using AI in the engineering process, the way that I see, or at least foresee AI in the very near term, getting most of its application, and even potentially in the long term, is utilizing AI to, one, be kind of a search engine and ask questions. So you create agents for certain kind of code investigations or things like that. It's got great application very near term for that. The AI agent framework works flawlessly for that. But where I also see a lot of potential impact, really near term within the next year to maybe 3 years, is utilizing AI in the code writing and programming side of things, because it's very good at writing, say, Python scripts and things like that. To essentially use it as a sounding board or a tool to do a lot of the in-between code writing, and then fine-tuning what it comes up with to create unique scripts that attack specific tasks that historically we would be leaning very heavily on design softwares like finite element analysis softwares and being reliant on those outside third-party vendors or those software vendors to create new tools and introduce them into your platform products so that you can then use those. I think a lot of that is going to start to change with the advent of AI and open source systems, where you've got a whole kind of new space where you can use those engines, but you can also communicate with their API platforms and things associated with that. And you can use the AI as a tool to assist you in writing codes to communicate with the API for these, traditional platform products. And a lot of that automation is going to come, a lot of that automation near term is going to come, I think, from AI being such a good tool at kind of like Shawn mentioned, taking care of the mundane code writing or equation implementation in, say, a Python script. As far as CAD goes, I think there's a lot of opportunity that for a lot of these platform products to really introduce new and faster features at an extremely accelerated rate, because they're going to be able to be using AI to improve their code writing capacity and efficiency. You're going to, I think, kind of say out to AutoCAD, hey, I really need this tool, or it'd be great if we could have this. And your response time, where it used to be 3 years, is now looking like 6 months kind of thing. So I think there's real kind of workaround impacts as well as near-term direct impacts that teams can use AI for.
Yeah, it's a good point, right? As a software vendor, like Anthony and I, we'll spend a lot of time just, having the engineers describe the application they're looking for, right? It's a 18-page Word document, poorly described, has nothing to do with software, but it describes perfectly the automated workflow that we have to turn into code, right? So bypassing those things and doing the context and the design tool, yeah, it'd be awesome. Let's see, who's next? Josue, you want to talk about any of this, man?
Yeah, thank you for the opportunity. I have some notes that I made some quickly here, and I believe that the main benefit, or how will evolve, especially on the substation design, will be mainly that AI will accelerate, obviously, the design process, and will make it faster than any traditional methods, and obviously that will bring an increment in the productivity and efficiency, right?
Right.
Especially using tools like SBS, folks, and any other 3D tool that already have built in some good automation. Now, I believe that the hard portion or the hard work will be upfront for engineers, depending on each workflow that utilities or engineering firm have. Will be able to delineate any kind of checklist type steps, like a gate doors, to check something or verify, or incorporate any language related to IEEE standards, or even specific utility standards. That hard work upfront will really pay off well, especially on the productivity. That's obviously one of the points. And the other one, in summary, basically the automation of the repetitive task, like I mentioned before, related to the checklist. If you can make sure that your checkpoints related to confirming that NESC standard, NERC standards, or any other maybe civil, obviously, standards, all the national standards can be confirmed as a counterpart of what is being designed in the drawings, and what is written in the drawings, as notes and things like that. There is a lot of work for engineers, just receive drawings back and making notes, making the reviews of those drawings. And if you can reduce that drastically using AI, is going to be a win-win, and I believe it will be even potentially even more accurate. Obviously, we have the human error in the middle, that we can try to make sure that if AI take care of that. So,
Yeah, no, that's a great point, right? And you think about the amount of work you spend looking up standards, and even from my IEEE standards, but internal guidelines as well, right? For most of the utility companies, it's, boy, you get a new engineer, it's like, here, read this 50,000-page document. You start Monday, right? You got to learn the company guidelines along with everything else that you need to know for engineering. So, yeah, no, that's a great point.
yeah.
So, Michael or Ben, anybody else want to weigh in before we move on next question?
Sure. Touching on some of the things that everyone else has already touched on. Shawn talked about automation and just like we try to simplify and standardize things for automation with our users, anything that you can automate, you can train AI how to do. So over time, we're already trying to automate a lot of processes just to make transitioning from one client to another easier when we're making our drawings. There's no reason we couldn't eventually have train up an AI agent or bot or whatever to then automatically just tell it, hey, take these drawings and make them compliant with this client. So I see that as a down the road thing, but with Microsoft Copilot and what they're doing with their Copilot Office tools or Copilot 365, I don't remember. They're already doing things like that where you can say, make this PowerPoint look like this PowerPoint, or put this Word doc into this Word docs format. So again, easily trainable, or not easily, but trainable because it's repeatable. Talking about how we can use, like Cory talked about using the AI for programming. I'm seeing that right now where I have layman drafters who are using just the regular Copilot Bing to write Lisp routines for things that they have a Lisp routine for, but they don't know how it works. So they're saying, all right, I need to do this, and I'm not sure why this one isn't working. So go write me a code to do this. And then using it, testing it, they're going through the whole process that a coder would do without any coding knowledge. So it's taking the low code, no code to a whole new level with some caveats that they're learning as they go. So they're learning what the Lisp is doing as they're making tweaks to it. So they're not just plugging in unknown code that they have no idea what it is. It just kicked it out from the AI. So they're using it as a learning tool and as a tool generator. I don't remember if it was, I think it might have been Cory or Josue who talked about having the AI. Don't remember what triggered the thought, but having the AI in the CAD itself, I'm seeing those already where just any tool that you open now has a welcome to the AI assistant for this product. It's Clippy all over again. And that's at this point fairly useless, other than a more advanced help search tool. But I can see it eventually getting to the point where it sees what you're trying to do in CAD and says, you're not like you're using this tool, and then just pops up a little help button on the side that just says, if you'd like to learn more about these different features, just click over here. And it's hopefully not intrusive, but just whatever tool you're using, you just get a help file over on the right side or something. That's just like, here's, if you want to learn more, here you go. And that's something that'll change and evolve over time.
Clippy used to knock on the screen, right? And really disturb you while you were working.
I miss Clippy. It was ahead of his time.
Yeah.
And then Josue did talk about using AI for technical translation. We're doing that. We're using, well, not necessarily technical translation per se, but each team inside of our grid group works for a separate client. Each client has their own standards, their own processes, their own tribal knowledge that isn't written down anywhere.
Right.
So we're trying to get all that stuff written down and then just throw that on a team SharePoint and then use a Copilot chatbot to then scrub all that and become your go-to agent or your go-to Q&A. So it's our FAQ bots. So if you have a team and you bring someone new onto it, they don't have to know who knows what on the team. They can ask this bot, who do I like? How does this client like this? How do I set up my standards? Or where's the checklist to issue for client review? Stuff like that. And that's all just each team can keep their folder structure updated, and the bots will just go through and scrub it, keep it up to date. So you're seeing some immediate impact of these bots right now, or these AIs right now, just in helping sift through all the different data we have, because we just keep getting more and more data all the time. And people only have so much bandwidth. So getting summaries and bullet points and all that has helped out immensely, just keeping people from getting too overwhelmed, just in the fire hose stage of just getting inundated with new information.
Yeah, right. Yeah. All right, man. Let's get on the next question here. One of my favorites. This is true. I've been enamored with generative design. I've just been looking at different ways we could generate substations, some of the simpler substations, and I want to get you guys feel for, do we think it's, is it going to generate station layouts that are going to blow our minds, different things we never thought of, cheaper, and some kind of radical substation design, or is it just going to, be able to more effectively place equipment? And how far do you think we could push that? And let's start with Cory.
I think I generative design is very much so close to my heart, especially the optimization side of this coin. And this is, we've talked about this in some of the previous podcast episodes with regard to what is AI versus, say, in this case, what's generative design. And this is one of those circumstances in which if you're not familiar with generative design or the tools to implement generative design practices, on the outside, it will look and feel very much like AI. Anybody who interacts with it and utilizes it from a tool standpoint will be like, oh, this is AI. But in reality, this is where I think has the most potential to have a direct impact in utility space on the engineering side of things. I think AI will have a lot of benefits from a tool that can be used again as that kind of probabilistic tool that can answer, you're okay with it giving two separate answers to the same question asked twice in a row. Whereas in engineering, you don't have that opportunity. You need to have the same response two times in a row to the same question. And this is where generative design really, in my opinion, plays a critical role in potentially introducing those looks, feels, tastes like AI, but isn't quite AI and has a structure to it in the back end. I think generative design has a huge potential in the utility space to be a game changer as far as accelerating our workflows and how we go about doing designs. One thing I will note in kind of a past work experience in the building design side of things, not so much in the utility space, you often find up front that you can very quickly figure out what the best floor plan might look like. You don't necessarily need a generative design engine to tell you that. And maybe you go through this huge effort to create an optimization, floor planning algorithm in Rhino, Grasshopper, and whatnot. And it took you a week to come up with this optimization tool, and you run it, and it comes up with a million options, all of which most of which you probably wouldn't have thought about, but you wouldn't have thought about it because you didn't need to think about it, because intuitively the human mind is very good at identifying optimization pathways. But that doesn't necessarily mean you don't make those tools. In my opinion, I think you make those tools to kind of increase your efficiency at getting to those optimizations. And I think, especially in the utility space, when it comes to kind of like nitty-gritty tasks, AI can play a really critical role in assisting in the generative design creation process, especially, again, when it comes to kind of creating those scripts for, say, a Grasshopper node point. If you want to create a custom Grasshopper node, but you don't know C# or you don't know Python, man, first thing I'm doing, I'm hitting ChatGPT, like, hey, can you write me a quick script that does this? And 2 seconds, it has written a script that I can now use as a node. Maybe it has some minor edits it needs. The most infinitesimally small amount of coding knowledge, and you can make some really impressive automations through generative design that you then implement into your workflows, your engineering workflows, and you sidestep the probabilistic response issues of AI, but you get all the optimization and automation benefits of kind of what AI is used for often. So I think generative design has a huge potential in the utility space to really change how quickly we create layouts, how quickly we create drawings, and how we frankly harness our data in these design processes.
Yeah, that's great. Yeah, I just saw one of these examples on GitHub for it was an assembly AI, and basically it would take a CAD assembly with multiple parts, and it would disassemble it and find the most unique, creative way to disassemble, and obviously the most optimized way to do it, and then it would write the instructions to reassemble it. So you give it something like IKEA furniture, and it would pull it apart, object by object, and it would reverse that and write the rules to do it at the same time. Now it can think of 1,000 ways to assemble something, right? Where most of us would just go at it, and once you're done, that's it, right? So, yeah, it's amazing to watch, and I think for substation, it would be interesting to do something like vehicle accessibility or something. Try to do that kind of generative process for it to see which ways that vehicles could enter the stations or the layouts. So, Josue, you want to weigh in on that generative design side?
Yes. Yeah, this is one of the topics that I believe is can evolve drastically in the future. However, I will say that one of the uh, benefits that it will help reduce time through just the initial portion of the design cycle, basically any conceptual design or initial stages, and is mainly I am focusing on the unconventional designs or unconventional configurations, where you can have a complex system in a maybe using an example of a big city, maybe Chicago, New York, any other uh, crowded city that have limited space, but you still have a very complex system. Um, how you accommodate a substation in an example, a small site. Many cases, you depend not only, and going back to what Cory mentioned, related to buildings. Uh, uh, it's not only create a building or create a site, but in the utility space, you depend on the system configuration. If you need a double bus, if you need a ring bus configuration, if it's transmission or if it's distribution. So, and you can think that you may be able to do it from a high level conceptual design, maybe using an outdoor design of a substation. But if you can do like a Trevor, you have the tool that you select the site, the dimensions, and you can input the maybe the system configuration or even the same AI. If you provide some inputs, it will identify it, and we'll say, well, maybe here you can, the best option or the only option could be just create a building and use GIS substations. Um, and I mentioned this because I had been involved for probably the last 2 years dealing with a utility that have these similar cases where space is very limited, and we think that yeah, we can put on a small substation there, but doesn't meet the technical requirements. Or we think that well, we can do a GIS substation in a building, but now we think that we can accommodate the building in this way. Well, doesn't work, maybe because the access to the trucks is not going to be the preferred method, it's not in a good
Right.
location. Well, all of that you can be scrubbed out and reduced to maybe one or two options that you say, yeah, that's perfect. That's
Right.
the way to go. So I think that the unconventional configurations and complex designs, especially related to spacing, it will be a huge, I would say, benefit to reducing time, especially, and a lot of back and forward just in the conceptual cycles.
Right.
Right.
Yeah, that's the ultimate, right? It's to quickly assess, maybe five different sites, five different building locations really quickly to find out are we even close, on any one of these five, or a lot of the outdoor ones we see there's like 10 spots they could buy. Which one should they really try to go after? All right, Anthony, you want to weigh in on some generative design?
Yeah, sure. So I think Josue really nailed it with the space constraints being really a benefit of having a generative design solution to fit into those spaces. I just want to touch on remind listeners here that generative AI in general is trained on existing data. So I don't really think there'll be any new configurations or layouts that haven't been seen before. But with the ability to explore thousands of configurations almost immediately, I think generative AI solutions will be ideal to find the most efficient, safe, cost-effective solutions, or even alternatives to existing brownfield designs if you're doing a rebuild or a partial rebuild. The benefit of using AI and a generative AI solution is using natural language processing that allows the user to just communicate with the program as they would be talking to any other human. So, for a substation configuration, there's a lot of constraints dependent on the environment. As Josue was talking about, the space constraints. There's also incoming and outgoing, transmission lines and feeders, distribution feeders, which are typically fixed, and adjusting those that can be extremely costly. So, having the ability to communicate this to the model, explaining the order of priority of the design, the model can then theoretically generate the best available configuration while taking all of those variables into account. So I think that's going to be the most impact there with a generative substation design. A lot of substation design is already standardized by the utility themselves, whether that's IEEE standards or just your electric maintenance or construction department standards. And some of those aren't even written down. So it's being able to communicate with those preferences with the electrical maintenance team to come in and put those inputs into your generative AI. So I don't see anything being truly unconventional, but more of a custom or novel fit for the specific environment, that will see different things that maybe you're not seeing as an engineer. There's thousands of configurations, especially when you're working in small areas, and especially when you have neighbors that aren't excited about you're putting a substation in their backyard, right? So it's taking that stuff into consideration.
Yeah, great points, Anthony. Yeah. Yeah. And like I said, generative design, right? Think of like the image generation, right? Facial generation and generate human faces because it's been trained on millions of faces, right? It could still make a novel face that doesn't exist, but it needed the millions of faces to get it going, right? So,
Yeah.
yeah, great example. How about Michael? Michael, you want to weigh in on the generative design side?
Yeah, I think generative design to me is pretty fascinating. It's extremely intelligent, based on the parameters that you give it, industry standards, client standards, stuff like that. I'd be curious to see it evolve to where you could have it pulling the weather conditions, soil types, and not just give the layout, but also best foundation types,
Right.
for a station. I think we're still a ways out, but it may not be too much to ask of it, considering its level of intelligence to potentially even do steel designs based on ice loading, wind factors, and things like that. So, I'm very optimistic of generative design, but from what I've seen of it, it seems a little limited compared to where I feel like its capability could go.
Yeah. Yeah, there you go. Well, the training for sure, right? But it's funny, Jack Hobson from Autodesk was we did a project with Forma and we'd pick St. Louis, Jackson, St. Louis, and we just picked a couple of sites and we did this analysis with it and we ran the generative design to go through the site sizes and pull things up. But with the new thing they had in Forma, we put in this Esri data. So it had all that historical data. So to Michael's point, and one of the sites was the cheapest. But we ran through and just chatting with it brought up the fact that there was a flood there in 1993 or whatever it was that flooded that land right where the site was, right? And of course, you would have looked that up or something, but it was immediately there. And we were just asking it to assess different sites, and it went through all this data instantly and came back with that as an answer. So, that stuff's powerful, but without the data originally, it wouldn't have been able to really come up with any answers for us. So,
just adding to your point, and I think that's where we want to go, Trevor, because imagine in the design process, you don't know the territory. Maybe you are working in California or you're working in Florida. You don't know
Right.
exactly, and then you propose and work with your team and maybe put even weeks of maybe 30% design, and at some point where the review process go back to the utility or to the client, and they will tell you, hey, no, but that's this is a very critical area, it's a floating area, or
Right.
you have to start over. But if you can have those kind of red flags raised at the beginning, you save a lot of obviously money and effort. So
Right.
yeah, it's very, very beneficial, that portion. Yeah.
Yeah, that's great. It's one point really from what you were saying originally, Josue. So there was, the IEEE standards during the design process, and then you got all the civil detail and historical information you could find up at the site locating side, right? So yeah, I think it's pretty powerful stuff. And I think, we are just scratching the surface, from what we can see it do now versus, where it's going to go. I can't imagine what's coming in 10 years. Originally, we said we'd talk about 5 years to 10 years. I moved it down to five because I can't even figure out 10. Who knows? We never knew we'd be here 5 years ago. So let's just do the next five.
I mean, from the first episode to this episode, we have already gone through like 2 or 3 different generations of generative AI that have gotten
Yeah.
significantly faster. So
Right.
it's impressive and
Yeah.
scary.
It is. Yeah, it's insane. It's actually a big danger for us developers because it's shiny object syndrome. Every week you could hit something new. This week it was DeepSeek. It's like, okay, we got a new one.
Well,
Yeah,
Alibaba just put out theirs, which is apparently better than DeepSeek V3. So
yeah. So we need a fourth episode maybe after this, but we'll see. All right, let's move on. Let's talk about one of my favorites here, legacy systems. I love that Shawn signed up to talk about this first. We call it like, dinosaur CAD to future AI. No matter how much new AI we do, I mean, utility companies, the infrastructure, the grid is old. Let's just say old. We're not in the automotive industry here with new cutting edge materials. We got a lot of old systems to deal with. And, how do you guys see this going? What are some, let's say, best practices? And Shawn signed up for this first. So Shawn, take us away.
Yeah. So, I've been writing software for the utility industry for almost 17 years now. I've written a few dozen applications at this point, and in every case, I've needed data. Every case, and that data tends to get locked up in use cases that may or may not be useful to the applications that we're creating. So if we're going to grow and prosper, whether it's AI or any other system that we create, we have to be more open in sharing with the data that is, that lives at the utilities. They have petabytes of information that is just sitting there waiting for a novel use case or a machine learning model to just eat and do something with it. And we ignore it, or it shows up on an executive's dashboard once a month, for some kind of bonus number or safety thing. We could do something with that. We've been running substations and transmission lines and whatnot for years and years and years. And we've been capturing that data from the day one. We might not have been capturing it electrically or electronically, but we were recording it on a piece of paper. And that piece of paper at some utilities, I guarantee you can go back and find still some of that paper. You might find stuff written on sheepskin for all I know. I mean, they keep stuff forever. It's the capabilities of digitizing that information and turning it into something useful has been around for a long time, and we need to do that. It's not novel what the utility companies do. They boil water and use that boiling water or that energy or whatever to spin a turbine to put electrons on a wire and send it to your toaster. Everybody's doing the same thing. So we should not be looking at our data like it's some proprietary, some chapter in the gospel that only we know. It's not the case. We need to unhand the data, and once we do that, we can do something with it.
Yeah. Yeah, great point. Yeah, like, it's every time we do one of these projects, right? We start digging into the data, and you could start with one of the newer, station designs, and you can get all the data, nice, even the 2D stuff. It could be vectorized because it was digital originally, even from a PDF, right? We can bring it back to vector and all this stuff. And then you dig and you get all those drawings. I thought you said sheepskin. It's just hand drawings and scribbled revision notes and just stuck in there. And, you got to scan it and try to do something with that with an AI model. And, it's just an absolute nightmare, but there is terabytes of it just sitting there and waiting to be trained.
Yep.
Anybody else want to talk about Dinosaur CAD or any legacy system before we move on?
Well, I think it's worth noting. Shawn had talked about this in the past, and I think it's worth just kind of re-emphasizing is that digital twins are great. 3D digital twins are great, and everybody at the company I work at knows that I'm a big fan of moving in a three-dimensional direction as far as designing goes. And I mean, but it really it doesn't have to be 3D to have intelligence. There doesn't even have to be a 3D model associated with it for there to be this intelligence behind it. I mean, Shawn has certainly been kind enough to share some of the individuals that he knows with regards to some of the businesses that they've started up with turning 2D print, the sheepskin that we were just joking about, and turning that into intelligent PDFs that you can interact with, that you can, connect code to and say, okay, this is representative of a substation out in the real world, and I want to be able to communicate with it. I think the term digital twin has inherently, for better or for worse, obtained this mental image of being a 3D representation of our designs. And for most of the time, especially moving forward now that a lot of designs are kind of in a 3D space due to the software advancements, that's just not necessarily, it doesn't necessarily have to be the case. And we have so much of that information just sitting on prints and storage rooms and things like that. And if there's some kind of a financial incentive, to be honest, I think there's theoretically a business opportunity there. There's some kind of financial incentive to encourage these utilities or these, even private energy suppliers, things like that, to digitize that information to where they can harness it and make money off of that data. I think that has a huge boon or benefit for the conversation of not just AI in the utility space, but technology in general, just in general in the AI space.
Yeah. Yeah, I agree. And it's funny, this whole digital twin thing has become this marketing fascination with, I still think it gets in the way because everybody still sees it as a dashboard, right? Where it reports things that already happen. We're not talking about predictive maintenance or anything really clever. We're still at the point where it's that, like Shawn said, once in a while an executive sees a dashboard or something, when the breaker's going to blow up in an hour because it's already spit out gas and it's going to blow. It's too late, right? But if we had, 50 years of historical data to train a model, they could do some predictions based on weather and historical fact and everything else. I mean, that makes that digital twin a nice predictive tool you could do some analysis with, right?
And that's the infuriating part about it for me, that we have the data. The utility companies are sitting on that data. They have 50 years of operational data for, the major equipment in a substation. And they use it to calculate safety numbers a month in arrears. And I'm like, oh my goodness, do you know what we could do with that?
Right.
They want to see someone else do it first, is the thing. They're not, this is a 100-year-old utility industry. They're not leading edge. They're trailing edge on everything.
I agree, but I'm going to say something very strong here. I believe that that's cowardice. Or if not cowardice, at least complacency. And both of those are really dirty words for me. I dislike both of them.
And I think those are fair. To be honest, I think those are, fair to say, but at the same time, these are also, they're still businesses. They still gotta make money. There's got to be financial incentive for them to do these things and release that data for X, Y, or Z reason. There's got to be a potential return on investment. Maybe you disagree with that, and I understand if you do. But I do think it's fair to say that, they're businesses, and maybe, in all honesty, there very well may be a business opportunity there in disguise.
I think there is. I'm going to jump off this soapbox in a second. Regulated utilities have no reason to push the boundaries, right? We don't compete like Southern Company here in the Southeast. They don't really compete with Duke. They don't really compete with TBA. They don't really compete with, FP&L south of us. There's no competition there. We swap, megawatts freely on the system just to keep everything running. And there's only a certain amount of profit that the regulated utility companies can make. So in a lot of ways, I believe that regulation actually limits innovation because there's no push to be better than your neighbor. And that's
the trade-off.
Yeah. I might say something even more controversial here. It's like the government,
There's the government
no need to be better.
Yeah.
And in addition to that, I want to add, and don't want to, you can edit this, Trevor. However, we are thinking, I'm sorry, obviously with an innovation mindset. Our risk levels maybe are, the tolerance is higher. Plus, not everybody is in the same way, right? Plus to that, we are a mix of generations within the utilities, and everything downstream is reduced to what? Risk. Not everybody is willing to tolerate risk in a 30-year career or in a very high-level executive position that maybe I don't want to test anything related to AI and operate it. It's you have those different mindsets, and then you may have a younger generation that already play with it and it's familiar with it. And it's can envision that in the short term. So I believe those two, the generation difference within the industry plus the risk tolerance, it will play a crucial point in the implementation of AI within especially the utility industry.
Yeah, what a great conversation. I think this could be a whole other episode here with it's amazing just the polar opposites, right? I mean, Ben just said it before in our third episode here of AI, it's changed so much we could probably start over and have a whole bunch of new topics in just a short period of time. And then, you meet a lot of people that, say, hell, I don't want to learn a new CAD system. I only got 9 years to retire. And I think 9 years?
Exactly.
9 years. In 9 weeks, our life changes completely in innovation. So yeah, it's just two completely different worlds. And that leads right into this next topic that we had outlined, which is, safety and compliance, right? And any utility company we talk to about AI, how do you keep it from going off the rails? What about our data? What if it's out there and it's shared with whoever, and now with DeepSeek, maybe it's China, but this is the number one topic that comes up all the time, right? And safety and compliance is such a difficult thing to have that conversation with utility companies. So let's go with Josue first. You talk about some ways that maybe we can have these discussions with the industry and talk about ways to keep AI from going off the rails.
Yeah, I think it's aligned with the previous topics or question that we already discussed, and there is not much difference in terms of safety, especially when utilities already have a bunch of standards, a bunch of process, a bunch of policies. In this case, maybe related to safety, maybe related to clearances and so on, that we are not inventing the wheel. But it's available, but not everybody. And again, it's the human error is in place where maybe the fast turnover it makes that we make mistakes, and it's kind of when somebody asks you, hey, what should be the clearance here in this utility? Well, I mean, the project manager send us all the standards and the special clearances that they have. So do you read it? Well, yeah, maybe I didn't read the whole 300 pages of the DCD, and so.
Yeah.
But obviously, being able to have that already as a database where AI can again go back to the checklist process and make sure that it meets the specific requirements. And it could be national standards and could be utility specific standards. Doesn't matter. But you can make sure that the person read it for you. The AI read it for you or verify it for you. If
Right.
for whatever case you forget to maybe read it, let's put it in that way. So I think this is again aligned to with the generative AI as well, and uh, any of the engineering processes that uh, you can have your checkpoints where you can make sure that the specific safety concerns or specifications are met in the design. So
Yeah. No, good point. How about Anthony? You want to weigh in here, buddy?
Yeah, I mean, this is a huge barrier to entry to a extremely risk averse environment here, right? So, it doesn't go without saying that this is something that should be on any utility or AEC firm's horizon here to make sure that they're giving quality products. I think AI-driven tools, they need to be transparent in their decision-making process to ensure that your engineers or designers can verify the results successfully and confidently. As an example, if I'm an engineer requesting an analysis by one of my engineering contractors to, say, verify battery system sizing, right? I need to see all of those inputs and outputs that were used to make the ultimate decision. If I'm going to put my name on this, that it's an approved battery system, that I'm increasing battery size, charger size, or whatnot, right? So it's not enough just to trust the output, especially when it's an AI system and it's not a human or an entire contracting firm that I can, interrogate in how they got to their answer. So I think a step in the right direction here are reasoning models such as O1 or our newly controversial DeepSeek model, which provides a historical output, right, of how it reached its output. So, this is especially important in industries like nuclear, where you have critical safety systems required to operate in an event of emergency. And without full transparency, the organization, not only the engineer, is taking a very large risk here. And part of this goes back to your data. So high quality data, you need high quality data to ensure there's no errors that could compromise safety. And it goes back to data in, data out. With low quality data input, you can't expect high quality data output. So, there's lots of data that these companies have, but that data needs to be parsed and put into specific formats, organized. The sheepskin drawing that we have here, right? That needs to be organized properly. And drawings with coffee stains all over them are probably highly accurate, but they need to be organized properly to have the right data format in and out. So it goes back to data quality, understanding the transparency in the model, how it was built, how you're getting your outputs, and something that's verifiable for an engineer.
That's awesome. Yeah, I think for my new add-in for CAD, I think I'm going to call it Sheepy. It's like Clippy, but it's a little sheepskin Sheepy.
You better get that one copyrighted.
Love it.
Yeah,
So
no, that's
Trevor,
Shawn.
just quick,
Real quick.
before we go. So Anthony said something right there that brought a memory back to mind. Coffee stain drawings, it could be accurate. That is absolutely true, but it's probably not. I remember distinctly going into substations and there were, drawings taped to the wall. And those drawings were taped to the wall and they were, seen as the most recent revision or whatnot, simply through human nature. people walk in, they look at it, they say, well, that's got to be the drawing because it's stuck, on the wall right next to this wiring captain or something like that. But then I could pull up, my mobile device, which I had access to our document management system, and I could literally see that those documents were 4, 5, 10, 20 revisions old. But because that they were physically present, taped on the wall, that was the gospel, according to the substation engineers. And, what all that leads back to is that we can't do good quality management. We can't do good QA/QC if we don't have good data. And that also means that you have to get rid of the bad data. You can't just keep it around just because you're used to keeping it around. You have to burn it with fire and bury the ashes, because this stuff will kill you. I mean, bad wiring in a substation will burn up equipment. It could hurt somebody. We have to be willing to do the hard job of cleanup and disposal.
Yeah, Shawn, you nailed it. I mean, as-bilting is a huge problem in the utility. And it just cascades, right? If you don't get your as-bilts in from one design, the next design just adds on to that problem. So as-bilting is a huge issue. Like you said, that there's definitely safety issues there with wires burning up, but tagging issues. If you're putting in clearance tags, you're holding tags, and something's not accurate, there could be significant violations there, and somebody can get hurt. So
that gets into like photogrammetry and having AI being able to go and just take a camera and scan the cabinet and have it route wires and whatnot for you, so you get an accurate live depiction. How much would make that?
Sheepy.
Yeah,
somebody should.
Y'all joke about sheepskin. I've definitely seen Mylar drawings at our company that get kept in the caves for 100 years. So
I love the caves.
Yeah.
Nice.
We have to maintain a copy, so they stay in a cave.
Or
Nice.
the old blueprints that are actually blueprints that smell like ammonia. Yeah.
Oh,
Real
yeah.
blueprints. Yeah.
Yeah, there you go.
Trevor, one thing I will note on safety and compliance, there again, I think all these topics could easily be their own episodes.
And on that note, we're going to stop this podcast right here because we had such a good time talking about these topics that there's going to be a bonus episode, which is also almost an hour long. So feel free to check in the next episode and find out more about our artificial intelligence conversation and all the great ideas that came from that one. See you next time. Thank you for listening to the Power Up Podcast today. If you enjoyed this conversation and you're not yet a member of the STSIC, join for free at stsconsortium.com. Be part of the community and all these great conversations. And maybe you'll be the next guest on the Power Up Podcast.